So let's find the mass of a bowl, and we'll in the shape of a hemisphere. So we'll model the bowl by x squared plus y squared plus z squared equals a squared for some a. And we'll only take z less than equals 0 so that we get the normal shape of a bowl that you would like pour cereal into or something. And the density we'll say is given by delta equals 1 minus z. So it's density 1 at the top and gets more dense as you go down. So we'll use spherical coordinates to parameterize this. So r of theta phi, if x is a is the radius, cos theta sine phi, y is a sine theta sine phi, and z is a cos phi. So theta, as usual, will go between 0 and 2 pi. But phi, since we only want z less than equals 0, remember that the xy plane is where phi is equal to pi over 2. So phi will only go between pi over 2 and pi instead of 0 and pi. All right, so we've worked out we've calculated the surface area differential of a sphere a few times. So let me just recall from previous computations that r theta cross r phi magnitude is a squared sine of phi. And even if you'd only done this in the case of a unit sphere, so a equals 1, you could deduce this formula by saying, well, if we scale everything by a factor a, then the area should scale by a factor of a squared. Okay, so we have the surface area differential. So now we can calculate the mass. So m is the integral over our surface, density with respect to surface area. So then this is integral, let's see, so phi will go from pi over 2 to pi. Theta will go from 0 to 2 pi. And then, so the density z is 1 minus a cos phi. And then our surface area differential is a squared sine phi, and then d theta d phi. So this way we can break this up as this is, so again, the theta, there's no theta in here, so that'll just multiply everything by 2 pi. And also the a squared is a constant. So this is 2 pi a squared integral pi over 2 to pi of sine phi d phi. And then this here we have minus 2 pi a cubed integral. This is getting, let's do that up here. So we'll have 2 pi a squared integral pi over 2 to pi sine phi d phi, then minus 2 pi a cubed integral pi over 2 to pi of cos theta, or sorry, cos phi sine phi d phi. So this becomes 2 pi a squared negative cos phi at pi and pi over 2. And then this we can move this inside to be 2. So this is sine of 2 phi d phi. And so that'll give us minus sine 2 phi integrates to so plus pi a cubed, since we moved the 2 inside, then cos 2 phi over 2 at pi and at pi over 2. So let's see. So cos of pi, so this will be 2 pi a squared. This one is 0 plus, and then so cos of 2 pi is 1, and cos of 2 times pi over 2 is negative 1, but then since we're subtracting that, so this will be 2, and that cancels out the denominator 2, so this will be plus pi a cubed. So if you want to simplify that, you could do, you don't have to, but you could write that as pi a squared times 2 plus a. And so this is the mass.